Greetings and welcome to the introduction to astronomy. In this lecture, we are going to be talking about astronomy and science a little bit in general and looking at some of the things that we will be studying. So this serves as an introduction to our very first chapter in the textbook. And we'll start looking at again some of the things that we will study in astronomy and just some things about science in general. So let's go ahead and get started. And we find first of all, what is astronomy? So this is a good question. Astronomy is the study pretty much of everything, the universe and everything in it. So you will see that we will be looking at a lot of different things in this class. And I give you some here that we can look at. And we'll be looking at things like planets and moons, such as the planet Mars seen here and many of the moons, hundreds of moons within the solar system. So we will talk about those. We will look at asteroids and comets. Here's an image of a comet as it stretches back across the sky. Those are some of the smaller debris within our own solar system. We will look at stars in some classes. And here's an example of a star cluster known as the Pleiades. And the individual stars often don't really look like much because they're just points of light. But we'll often study things like star clusters in some of the classes. We'll look at galaxies such as the spiral galaxy seen here, perhaps somewhat similar to our own galaxy, the Milky Way, if we could look at it from outside. We will look at nebulae. Here's an example of a nebula. And a nebula is often, depending on the type of nebula, can be a star forming region. And there are also nebulae that are present that are the end states of stars. So the debris left behind when a star dies. We look at black holes, and here we see an artist's conception of material swirling into a black hole. And of course, much more. So lots of things that we will be looking at over the course of the semester. Now, what you study depends on which class you're taking. So some of my classes will focus just on the planets and will focus on these first two. Others will look at things outside the solar system and look at the other areas, stars and galaxies. So really what we study depends on the specific class that you are taking. So why do we study astronomy? Well, one of the reasons is that astronomy is a very general science. It's nice in that you get a little bit of a taste of everything. So we will see some chemistry, biology, geology. We will look at all of the other sciences, physics, as well as astronomy. So in order to study astronomy, even at the introductory level, you will see a little bit of all of these other sciences as well. The other idea is that studying any other science or astronomy teaches a way of thinking and a way to critically analyze information and apply that to everyday situations. So a way to analyze things that we see and think about them. It also gives us a better understanding of our universe and where we fit into the universe. And we will look at that coming up in a future lecture. So let's take a look at what we mean by scientific thinking here. And what we have is, what do we mean by scientific thinking? Well, some of the terms that we look at are terms like hypothesis, which is a proposal. So if you've ever done a science fair, science project, you often come up with your hypothesis, which is something to explain. What are you going to either verify or prove false? So for example, you could do something like it was done in ancient times when the sun was observed to rise in the east every day and then set in the west. That meant that the sun must orbit the earth. That is a perfectly reasonable hypothesis because it is something that can be tested. We can keep testing it. And does the sun keep rising in the east every day? Now, the idea is that you have to continually test it, and eventually you may find some condition that would be predicted by your idea that the sun rises in the east, and some other prediction that would make that the sun orbits the earth, that would find that this would not be true. And that's why I say that it must be testable. So an example, if we want to say that the moon is made of green cheese, that is a valid hypothesis in that it is something that can be tested. So you can take samples of the moon and find out what it is made up of. But it is something that is testable. Now, a hypothesis differs from a theory in that a theory is a hypothesis that has been tested many times and has stood the test of time. So when we start calling something a theory, it is been very well tested. So a hypothesis is generally the beginning, and then a theory would be the next step. So when you say something is just a theory, you sometimes hear that. That's really not a good way to think about it. Theory is based on years of observation and study that kind of demonstrate that this seems to work in most situations or all situations. It's been continually tested. The other thing that we look at sometimes is the scientific models. So it's a simplified representation. When we study atoms, we simplify the way we look at them in order to be able to easily understand and easily try to determine what is happening with them. So an example of this is that if we're studying the sun, we might assume that the sun is spherical. Now, in reality, the sun is not quite spherical. It's a squashed sphere. However, when you're doing detailed calculations, it's far easier to do them with a sphere than with an ellipsoid, which would be the actual shape of our sun and of some of the planets. So it makes it easier to do this. And we do these models that do make simplifying assumptions simply to be able to understand and explain things better and to better be able to test various hypotheses as we're looking at those. Now, we also want to look at the scientific method is an ongoing process. So it never ends. It continues onward. And that's why we show it in a circle here. So you might start with making observations which lead to questions that will come up. And then those questions might lead you to a hypothesis, which makes different predictions. And then you can do an experiment to continue those and make more observations. And it's a continuing cycle because the whole idea behind the scientific method is that it continues onward. Now, there's a couple things that can happen. You can make your predictions and you can test them, and they might be correct. That's great. So if you find that your prediction is correct, then you find that you want to make more predictions. You want to continue this. So a theory is really never proven correct, although it can be proven wrong. So when we look at a theory, we consider what might be done there and what other things, how we can continue to test it and push that theory to its limits. Now, if you find things to be incorrect, well, that's a little bit of a problem. You may be able to modify your hypothesis. Maybe you can make some adjustments that will fit this data. And we'll look at some examples of that over the course of the semester. Although sometimes it's just so bad that you actually have to stop and reject your hypothesis and come up with a new hypothesis to continue this cycle. So you may be able to adjust your hypothesis here, or you may have to completely change it to move on, depending on the observations that you make. But the whole key is that things are continually tested. So even things like relativity is constantly being pushed to its limits, even though it's been around for over 100 years now, to be able to see where the limits of it are. And that allows us then to better understand things in the universe. So let's go ahead and finish up here our lecture with our summary. First of all, we talked about astronomy and how that is the study of the universe and everything in it. And we looked at a few examples of that. We study astronomy to learn a specific way of thinking, the scientific way of thinking. And we looked at the scientific method as a never ending process that allows the theories and models to be continually refined and improved. So that concludes this lecture on astronomy and science. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.